Professor Patrick again, back from our break. And we're here to talk about Python strings part 2. Hopefully you got a lot out of the first part of this two-part video series on strings in Python. Learned all about how to create strings and ways to reference the components of a string and format strings as well. Now we'll talk about some methods we can use with Python strings: searching, formatting, Boolean tests, and some more. We'll pick up from where you took a break. We're in that same notebook that we used before. The bit.ly to get to the notebook is bit.ly/Python strings with the P of Python and the S of strings capitalized. So let's talk about some methods. We'll talk about some formatting methods. We talked about embedding values in strings when we talked about the format method itself, but there are a number of other methods that we can use to help format strings. We can use the strip method if we want to remove some characters from the beginning and the end of a string. This can come in handy when we're reading data from files or we're reading large multi-line objects of strings, if we want to do a little cleanup. Here, the strip method is going to look for NOTH. It's looking for this substring NOTH. And it's going to strip that out of the variable string object that we created with 30 days of Python. And so if we run that, we get, instead of 30 days of Python, we get 30 days of Python, basically pulling out the characters N, O, T, or H anywhere in that string. Doesn't matter how many instances of any of those characters that occurred. You can see we had multiple instances of T's, we have multiple instances of O's and N's, but they all get removed. They all get removed. Lower is really handy, especially when we ask users for input. If we ask users for input, we don't really have control over what they type. Sometimes users will type all in lowercase for us. Some users may type in mixed case, maybe sentence case or title case. Some users perhaps in all uppercase. And if we're going through and evaluating input that users have provided, it's really handy to be able to take the user input and turn it all into one case, either lower or upper. And we have a method for each. The lower method will if we apply the lower method to a string, then it will basically return all the characters in that string, but in lowercase. So in this example, we've assigned that string 30 days of Python to a variable we call string object, and then we invoke the lower method on string object in the middle of this print function. So you can see we have the variable name string object. We use dot notation to refer to the method. The method we're using is lower, so we put dot lower. Methods are like functions. They can take arguments, so we put a pair of parentheses after the method name. And if we invoke the lower method on that string object, we get it all in lowercase. The upper method does just the opposite. It takes whatever the string was and it gives us back the string all in uppercase. We can also change the format of the capitalization of the string with the capitalize method. This will go through and put a capital letter or an uppercase character at the beginning of every sentence. So in 30 days of Python, it gives us 30 days of Python with a capital T at the start. Title case is similar, but title case will give us a capital letter at the start, at the first character of every word instead of every sentence. And so we get 30 days of Python back from an all lowercase instance of 30 days of Python. We get it back with capital T, capital D, capital O, capital P. Swap case sort of jujitsus the case around. whatever the case of a character was in the original string, swap case it flips it to the other. So uppercase becomes lower and lowercase becomes upper. You can see that in the two examples in the code here. Expand tabs will go in to those special characters, the tab characters that we talked about before, the escape sequences for tab characters, and it will basically fill them in with spaces. If we don't pass an argument to expand tabs, it will use the default tab size of 8 spaces. If we prefer a different tab spacing, we can just provide an argument, an integer argument with that tab spacing. And here we've done invoking of expand tabs on that string object with no argument and gotten the default spacing, and then we gave it an argument of 10. And you can see we got a spacing that's a little bit bigger. Our notebook tells us the default tab size is 8. It looks to me that it's more like 4 in Colab. So you'll want to check that in whatever system you're using. Format we talked about before in the first video. The one thing that we want to be careful about with the format method is the sequence of the arguments needs to match the sequence of the pairs of curly braces in our text. You can play around with those here. We've tried them in the last video. Let's get into some other string methods that we can use to evaluate a string. One that's handy is the count method. We can use the count method to count the number of instances of a substring in the string object that we're invoking. So we can pass an argument or multiple arguments to the count method, and we'll get back a count of the number of times that substring was found in the string object. If we'd like, we can pass two integer arguments following the substring. The integer arguments are the starting index value and the last index value. So basically, what slice or range within the string that we should be searching for that character. So in our first print statement, we simply asked how many times do we see the character lowercase y in that string object that has 30 days of Python, and we see it 3 times. The second print statement is looking for that lowercase y, but beginning at the 7th index position and going to the 14th index position in the string. And in that range, we only see it once. We can search a string. This will return a Boolean in some cases or a count in others. The first one we'll look at is ends with. We can use this to test whether a string ends with the substring that we pass as an argument. So again, we'll use that string object of 30 days of Python. If we want to see if that ends with on, we can pass that substring in as an argument to ends with and invoke that ends with method on the string object. And we should get a response back that that's true because it does end it ends thon. The second print statement looks for the substring tion, and that's going to return a value of false for us because the string object doesn't end tion. We can use the find method. This is different from the count method. The count method will go in and count every instance that it finds. The find method will come back and tell us the location of the first occurrence of the substring. And if it doesn't find the substring, then it will return a -1. It doesn't return a 0 if it doesn't find the substring, because then we wouldn't be sure if it found the substring at index position 0 or if it didn't find the substring. So when it doesn't find the substring, it's returning a value of -1. And we've got 2 examples here. We look for lowercase y in 30 days of Python. Let's throw a third one in here. And I'll save the notebook back with this so that you have it as well. But let's look at what happens if we ask the find method whether there's the substrings z in 30 days of Python. And you can see we get a -1 there. I'll go back at the end of our video and save this notebook down so you have that new line of code in there. Our find is a reverse find. So while find begins at the start of the string and works its way through the elements of the string, reverse find starts at the end of the string and finds the first instance that occurs by beginning searching at the end. So the last instance of that substring. Index position can be used to find a substring within the string and its index position. We'll run this one. We're looking for the substring of DA, which is the beginning of the word days in 30 days of Python, and we see that begins at index position 7. If we give it an argument that is going to return an error message, if we give it an argument with a value that is either beyond the range of the elements in the string, or the substring is not found beginning from that position, that index position onward, we'll get an error message. We can also get the highest index value of a substring. This is sort of like a reverse find, but a reverse index, looking for the index value and the highest instance of that. So for the substring DA, it only occurs once. We'll get the same value back. If we look for the substring ON, we'll get the value 19 when we invoke this one. And we'll get an error message if we give it a value that throws it out of range. There's some Booleans. We got one Boolean result earlier with one of the methods that we looked at, and that was ends with. We can also ask if a string starts with a specified string. And perhaps to make it a little cleaner for you, I'll move the ends with method down here in the notebook alongside the starts with method. So you've got all the Boolean ones together. But starts with will evaluate the string, looking for whatever substring we provided as an argument, and return a Boolean value. Here we're looking for 30 first in the substring, first in the string 30 days of Python with the word 30 spelled out. But then we changed the assignment to string object, and instead of spelling out 30, we put the number 30, and of course we don't find the substring THIRTY in that string. Is alpha numeric is another method. This tests the string to see if all the characters in that string are alpha or numeric, and it returns a Boolean. We've got a number of examples here. The first two return true because if you look at the characters in those strings, they are either alphabetic letters or they're numeric values. The second or the third and fourth example, they return false because of the spaces, because the spaces that are in those strings. Spaces don't count as alpha or numeric. And so we get those results back. Similarly, so that's a test for alpha or numeric. We can also test to see if all the characters in the string are alpha, if they're letters of the alphabet. On our first attempt, 30 days of Python has spaces in it, so that's returning a false for us. The second test that we did here with 30 days of Python with no spaces in it, that's returning true. Doesn't matter the case, upper or lower case, as long as they're alphabetic letters. And then finally, in the third test, we created a different variable called num, and we assigned the values 1, 2, 3 to it. They're not numeric, they're a string, they're in quotes, but they're not alpha characters. So is alpha returns false on those. And then in a similar vein, we can use is decimal to test to see if all the characters in a string are decimal values. And we can check to see if all the characters in a string are digits with the isDigit method. And then finally, isNumeric is a way for us to test to see if all the values in a string are numeric. So even if evaluation of those values results in a numeric value in scientific notation or some other notation, it will return back as true. However, finding a decimal place in there is going to give us a result of false. We can test a string to see if it would be a valid identifier. That is, could we use it as an object name in Python? Rules for object names, they can include digits and characters and underscores, but they can't start with a digit. And so our first test here, with 30 days of Python beginning with a 30, this will return a false for us. And the second one qualifies as an identifier, so returns a true. We can also test to see whether all the alphabetic characters in a string are either lower or uppercase. And we use is lower or is upper for those two tests. And you can play around with that in the notebook as well. So those are a number of methods. I want to just kind of shift gears a little bit and talk about slices and some set operations. These are methods as well. Two of them that we use quite often are split and join. Split takes a string and splits it into a list of smaller strings. By default, split will split every place it sees a space. So in essence, it can take a string that's a sentence and split it up into the words of the sentence. Join does the reverse. We join on a connector. So a space, in my example of splitting a sentence by the spaces, a space character could be a connector. And if we had a list of words, we could use the join method to take that list of words and join them together with that space as a connector, basically perhaps constructing a sentence out of a list of words. So there's some examples here. If we don't specify a connector for split, then split uses a space as the default. Our first example, we give the split method a space as the delimiter to use in breaking up this string practical data science. And you can see we get a list back with the string practical, then the string data, then the string science. If we go back to our string object that had 30 days of Python in it, and we invoke the split method, and note here we're not passing any argument to the split method, but that's okay. It's going to assume the default value of a space for the delimiter, and we'll get that list 30, then days, then of, and Python. And we can use any character or string of characters as a delimiter. So in this example, if we had 30, comma, space, days, comma, space, of, comma, space, Python, and we wanted to split on a comma and a space as a delimiter, we could do that, and we'll get that same list again of the strings 30, days, of, and Python as a list. We could split on a tab character or on the escape sequence for a tab character. This is really handy. Later, when you start working with data files, you'll oftentimes work with a type of data file called a CSV file, or a comma separated values file. In a CSV file, columns of data or fields are separated, their values are separated by commas. But sometimes you have data that has commas in it. Think of an address field, the street part of an address field. In the case where you have commas in your data, you could save it into a text file that's tab delimited instead of comma delimited. This is a tab separated values file. Many times people will save separated values as CSV files. They'll give it the extension CSV file, but the data itself is delimited with tabs. It's okay. You know that you can break it into separate values for each column if you use the split method as you're reading each line. And we have an example here that we have 3 lines of 3 strings that we assign to 3 different variables, but they could almost look like 3 lines in a file that you've read in that's tab delimited, where we have first name, last name, and email address. And if we use the split method on each of those variables, then we get a list of first name, last name, email, then Aaron for first name, Rogers for last name, and perhaps Aaron Rodgers' email address, maybe not, and likewise. If we go to split a string on a delimiter that doesn't exist in the string, we simply get the string back. We get the string back, but we get it back as a string in a list, a string in a list of 1. So here's a little exercise to play around with respect to the split method. In your copy of the notebook, if you'd like, you can pause and try this exercise. Take this string billgates@microsoft.com and write some Python code that pulls the username out of that email address and the domain name out of that email address using the split command. See if you can do that. Pause the video if you like while you do it. Then we'll continue and we'll talk about the join method. So that was split. The join method, basically, as I said at the start of our discussion, the join method needs a connector as a string, and on that string you invoke the join method, and you give it a list of strings to join together on that connector. So as an example here, we're using a space as the connector, and we're joining the string variable webtech that we created. That's a list of strings, HTML, CSS, JavaScript, and React. And the result we get back is one big string with those all separated by spaces. We can use any connector we want. Just kind of playing around, we could try a hash mark, asterisk hash mark as the connector, and that's the result that we would get back. I think our comment's off a little bit. Our comment has just the hash mark part in there, but that's okay. We'll fix that. Then finally, replace is a method that looks for a substring. We give it 2 arguments. It looks for the first argument in the string that we invoke it on, and it replaces that first object with the second object. So we've assigned the string 30 days of Python to the variable string object. We're invoking the replace method on that string object. And the arguments that we're giving the replace, I do this a lot in Colab. I try to highlight things with the mouse, and I end up dragging things. That would have blown up. Okay. Stop trying to highlight. So I've got 2 arguments here. I'll go underneath them. I have first argument is the substring Python. That's what I'm looking for in my string object. Second argument is the word coding. Wherever I find Python, I'm going to replace it with coding. And so I get back 30 days of coding. We can use that as kind of a sneaky way to delete things. we could just, as a second argument, I'm falling back into highlighting again. As a second argument, if we just pass an empty string, right, just two double quotes or two single quotes, if we have this string object, I was typo typing and typo made typo many mistakes typo, and we go looking for space typo and replace it with an empty string, then let me get that out of the way. Then we get that string back without all the typos in it. So another exercise for you, and actually the tail end of the notebook has quite a few exercises. They cover everything from part 1 and part 2 videos that we went through on strings. But here's one to play around with before you get into the long list of exercises. There's a lot of typing to it if you do it from scratch. So we've given you in the notebook, we've given you a big long string that we've assigned to a variable GLK babe, like good luck babe. And it's the lyrics of the song Good Luck Babe. Use that string, use GLK babe, and see what Python code you could write to determine how many times the word good is used in the lyrics of Good Luck Babe. And write your code so that the word good is counted regardless of the case in which it occurs, whether it's lower, upper, title case, whatever. You want to know how many times in Good Luck Babe the word good is used. You can try that exercise out, play around with that, and then drop your code in here if you like. And then there are quite a few more exercises at the bottom of the notebook. These are all, I think, really helpful ways to kind of exercise a number of things that we went through in these two videos. So when you have a chance, take a stab at these exercises. Most of them are pretty quick and easy, and they'll get you some familiarity with working with strings. So I hope that was all really helpful for you. As I mentioned earlier in the video part 1 on formatting, the appendix here talks a bit about that older way to format strings. But I would recommend, for formatting purposes, I recommend that you stick with F strings. Thanks for listening.